Welcome viewers. So here's another example. You have to prove for any positive integer n, this expression is divisible by 3. So meaning this our proposition, our Pn is what 2 raised to the power of 2n minus 1 plus 1 is divisible by 3. Is divisible by 3. So meaning this is divisible by 3. And you know, anytime you are proving by induction, you test when n equals to 1. Is it true that the statement is true when n equals to 1? Then you assume that the statement is true when n equals to k. Use that assumption to prove that when n equals to k plus 1, the statement will still be true. Now let's check when n equals to 1. So we have 2 raised to the power of 2 times 1 minus 1 plus 1. 2 raised to the power of 2 times 1, that's 2. So now we have 2 minus 1 plus 1. 2 minus 1 is 1, so that is just 2 raised to the power of 1, which is 2 plus 1. 2 plus 1 is what? 3. Now the result we have here, you know, when n equals to 1, we got 3. Is 3 divisible by 3? So that is no doubt 3 is divisible by 3. Now meaning for n equals to k, our proposition will now be in form of k. So meaning 2 raised to the power of 2k minus 1 plus 1 is also divisible by 3. Is divisible by 3. So that's our assumption. You know, test for 1, assume n equals to k, and use it to prove that n equals to k plus 1 is true. Now, since we assume this is divisible by 3, it means this one is multiple of 3, right? It's multiple of 3. Now, what we just need to do is to check what of when n equals to k. So now, let's prove for n equals to k now. So now, n equals to k plus 1. Sorry, k plus 1. Now, go back to the question and let's put k plus 1 wherever we see n. So now we have p k plus 1. So that will be 2 raised to the power. Instead of n, now we have a k plus 1. Oh, sorry, there's 2. 2n, that is 2k plus 1. Then minus 1, as we have it, then plus 1. Let's simplify this. We have a 2 raised to the power of 2k plus 1. You know, when you open this bracket, you have a 2k, 2 times 1, 2 minus 1. This is what you're going to have as the index. You can see this 2k, 2 minus 1. So 2 minus 1 is 1, and that's why you have this. Then plus 1. Now, this is what we have. How do we know this is divisible by 3? What you just need to do, compare what you have here with what we have here. Compare the two. What do we observe? Are they the same? They are not the same. This is raised to the power of negative, but this is plus 1. Meaning, if I want to make them the same, okay, we can still do it here, but we can even before expansion we can get that right here. Let me just expand. You know, we want to prove. So now we expand. We have a 2 raised to the power of 2k plus 2 minus 1, then plus 1. Ordinarily 2 minus 1 will still give us a 1, which is what we got earlier. But because of, for the purpose of proving, so for the purpose of proof, so we don't want to get that result immediately. want to use this statement now. Now, what you just need to do, compare what you have here with what you have here. 2k, 2k, minus 1. This are minus 1, but there is plus 2, Abby. And that plus 2, let's separate it so that these two will look similar. So I will write it as a 2 raised power of 2k minus 1 plus 2, then plus 1. I just move that 2 to the back. So these two are looking similar now. This plus 1 is there, but you cannot separate this like that. So what we need to do, we are going to apply the knowledge of indices now. I'll use it to separate. So now, so that we have a 2 raised power of 2 dot 2 raised power of 2k minus 1. This is what you have there, plus 1. Despite this, we cannot say these are not similar. They are not yet similar because these two multiply this. Now, but to make this look like this, I will need to introduce 1 to this one. How do we do that again? It's very simple. This 2 raised power 2 is 4. So I will write this as 4. Bracket 2 raised power 2k minus 1. Ordinarily, you can write this as this. You can still put your bracket. Now, to make them the same, there's addition of 1 here. Let me just say, okay, plus 1, then minus 1 at the same time. Then don't forget we have 1 outside. Because 1 minus 1 will give us 0. Once you get 0, you are coming back to this. But for the purpose of what we want to get, so we are going to leave it this way. Now, what else to do? What we only need to do now, we have this equals similar to this. So I just need to remove this minus 1. How will I do that? I can regroup this as a 4, open bracket, 2 raised power of 2k minus 1 plus 1, then minus 4 plus 1. What I did here is, I used 4 to multiply both here. Since they are similar to where we are going, we know that this is divisible by 3. So now I carve away this so that I have 4 times minus 1, which is minus 4. Then plus 1, which is outside. And minus 4 plus 1 is negative 3. You know that? So now from here we have a 4, open bracket, 2 raised power of 2k minus 1 plus 1, then minus 3. Now, this is what we have. When n equals to k plus 1, we have this result. Minus 3 is divisible by 3. This itself is divisible by 3. And multiple of 3 multiplied by any whole number will still give us multiple of 3. So because of this, we say this is divisible by 3. This is divisible. This part is divisible. This is divisible. Addition of 2 multiple of 3 will always be divisible by 3. So from here now, we conclude that this statement is true. It's always true. It's very simple. The first step, test for n equals to 1. That is tested. 3 is divisible by 3. The next one, you assume. So, and in our assumption, we say this is divisible by 3. Abi? And this is similar to this. The only difference is just our k is replaced with letter n. Now, we check and prove this for n equals to k plus 1. So now we do that. We do some computations and manipulations without any force in it. There is no error. It's only that we try to express it in such a way that is divisible by 3, and that is what we are able to show. This is divisible by 3. A number that is divisible by 3 multiplied by 4 will always be divisible by 3, even when you take 3 from it, which is this. And that is just the conclusion.